Think about how we usually build .NET applications. Whenever we build a .NET application that interacts with the database or another Azure service, one of the first things we configure is a connection string. During development, we usually keep that connection string in appsetting.json. When we deploy to production, we move it to environment variables. And in many enterprise applications, we go one step further and securely store it in Azure Key Vault. Now, if you notice here, no matter where we store that connection string, our application still depends on secrets to authenticate. We have definitely improved how we manage those secrets, but have we actually changed the way our application authenticates? So here is the question. Are we solving the real problem? Or are we simply moving our secrets from one place to another? Let's answer that by looking at a real .NET application. Here we have our .NET application, and let me open this appsettings.development.json file. You can see the database connection string here. This is something we are all familiar with in our applications. The application needs to connect to the database, so we provide the server, database, username, and a password as a part of the connection configuration. And during local development, having configuration here is quite common. But the important thing for us is this password. Our application needs this credential to authenticate with the database. And obviously, when we deploy this application to Azure, we don't want to publish this password along with our application. So what do we normally do? We move this configuration outside the application. Let's see one common way of doing that in Azure. Here we have our application running in Azure App Service. Azure gives us a way to configure application settings outside our deployed application. So instead of keeping the production database connection configuration inside appsettings.json, we can configure it here as an environment variable. This is definitely better than putting a production password inside our source code or deploying it with our application. We can change the configuration independently of the application, and our production credentials don't need to live in the repository. But notice something here. The application still needs the same secret. We haven't removed the password. We simply changed where the password is stored. And this is where many applications take the next step. Instead of storing the secret directly in application configuration, we store it in a Azure Key Vault. Azure Key Vault gives us a dedicated service for securely managing sensitive information such as secrets, keys, and certificates. So instead of keeping our database passwords directly in application configuration, we can securely manage that secrets here. This gives us centralized secret management, controlled access, auditing, and a better way to manage the lifecycle of our secrets independently from the application. Compared with a putting password directly inside the appsettings.json, this is a significant improvement. But there is a still one important find: the secret still exists. Key Vault solves an important problem. How do we manage secrets securely? But what if our application didn't need that database passwords in the first place? We have improved how we manage the secret, but we haven't changed the authentication model itself. So, what if instead of giving our application a username and password, we give the application an identity? And that's where the Azure Managed Identity comes into the picture. Managed Identity allows our application running in Azure to authenticate using its own identity rather than relying on credentials that we have to store and manage. So, what exactly is a managed identity? Think of it as an identity that Azure provides to our application. Just like a user has an identity in Microsoft Entra ID, our application can also have an identity. We don't have to create a username, create a password, store credentials, or rotate those credentials ourselves. Azure manages the underlying identity credentials for us. When we host our .NET application in Azure App Service, we can enable a managed identity for that app service. Azure then creates an identity for that resource in Microsoft Entra ID. But having an identity does not automatically give the application access to everything in Azure. The identity still needs the appropriate permissions on the resource it wants to access. In our example, that's Azure SQL Database. So instead of saying, here is my username and password, please let me connect, the application can effectively say, this is my identity, I am authorized to access this database. That's the fundamental shift we are making from credential based authentication to identity based authentication. Now, the next question is, how does this actually work behind the scenes? Let's look at this flow. Here we have our .NET application running in Azure App Service, and we have enabled a managed identity for that app service. When the application needs to connect to Azure SQL, it doesn't look for a database username or password. Instead, it obtains an access token for Azure SQL using its Azure identity. Microsoft Entra-ID issues a short-lived access token for that identity. The application presents that token to Azure SQL when opening the database connection. Azure SQL validates the token and identifies which Microsoft Entra identity is making the request. But authentication alone is not enough. That identity must also be authorized inside the database with the permissions our application actually needs. If the identity is authorized, Azure SQL accepts the connection and the application can work with the database normally. So, our application doesn't need to know a database password. It authenticates using its identity and short-lived access token. That what makes this passwordless from the application's perspective. Before we implement it, there is one distinction worth making a very clear. Key vault and managed identity are both important, but they solve different problems. Key vault help us securely manage secrets that we actually need. Managed identity can remove the need for the application credentials when target Azure service supports Microsoft Entra authentication. So managed identity does not replace Key Vault. In fact, an application can use managed identity to authenticate to Key Vault itself. The key difference is simple. Key Vault manages secrets. Managed identity allows us to authenticate using identity instead of managing credentials. And that brings us to passwordless authentication. Passwordless does not mean authentication disappears. Our application still has to prove who it is. The difference is that we are no longer giving the application a database username and password that we have to store, protect, and rotate. Instead, the application authenticates using an identity. Microsoft Entra ID verifies that identity and provides a token that can be used to access the target service. So, authentication is still happening. We are simply moving from credential based authentication to identity based authentication. Now that concept is clear, let's see exactly what we are going to build. Our .NET application will run in Azure App Service. The app service will have a managed identity. This identity will authenticate through Microsoft Entra ID, and we will authorize it to access our Azure SQL database. There will be no database username or password in this application. Now let's turn this architecture into a working solution. First, we will prepare Azure SQL and make sure Microsoft Entra authentication is available. Then we will create the Azure App Service that will host our .NET application. We will enable managed identity for that app service. After that, we will authorize that identity inside Azure SQL. Then we will update our .NET connection configuration so there is no database username or password. Finally, we will deploy the application and verify that it can access Azure SQL using identity-based authentication. So let's start with Azure SQL Database. Now let's create our Azure SQL Database here. I have selected the subscription and resource group for this demo and provided the name for the database. The database needs a SQL logical server, so I will create one here. I have provided the server name and selected Central India as the region. Now here this is the important setting, that is authentication method. Azure SQL supports traditional SQL authentication with a username and a password as well as authentication through Microsoft Entra ID. For our solution, I am selecting Microsoft Entra-only authentication. We don't want our application depend on a SQL username and password. Instead, we are preparing Azure SQL for identity-based authentication through Microsoft Entra ID. I have also configured my Microsoft Entra administrator here. We will use this administrative access later when we authorize our application's managed identity inside the database. And just to make this distinction clear, we are not enabling managed identity on Azure SQL. We are configured Azure SQL for Microsoft Entra authentication. The managed identity will belong to our application. Let's create it. Our Azure SQL database is ready with Microsoft Entra authentication configured on the SQL side. Next, we need an application with its own identity. Our database is ready. Now let's create the application host. I'm selecting same subscription and same resource group here. Provided the web app name here. Just select the runtime stack here as our .NET 10. I will keep the region aligned with the rest of the demo and use a suitable plan for this demonstration. I will keep the remaining settings simple and create the app service. Now our application host is ready, but it doesn't have the managed identity we want to use for Azure SQL. So let's enable it. Here in our web app, I will go to the identity. You can see we have two options here, system assigned and user assigned. For this demo, we will use system assigned managed identity. This identity is directly associated with this web app and Azure manages its lifecycle along with the resource. So I will simply change the status on and save it. And that's it. Our web app now has its own identity in Microsoft Entra ID. We haven't created a username, we haven't created a password, and there is no client secret for us to manage. Azure manages the identity for us. And here we can see the object ID representing this identity. But having an identity alone doesn't give our application access to the database. We still need to tell Azure SQL that this identity is allowed to access it. So that's what we will configure the next. This is the our database we created earlier. To give our web app access to the database, I will connect to the Azure SQL using SQL Server Management Studio. And remember, our SQL Server is configured for Microsoft Entra-only authentication. So I am not going to connect using a SQL username and password. I will connect using the Microsoft Entra Administrator account and that we configured earlier. So copy this server name and let's connect with the SQL Server Management Studio. Let's connect the database engine. Here, I will enter the Azure SQL Server name that we created earlier. Select the Microsoft Entra MAP. And this is my Microsoft Entra identity, which we have configured as the administrator for this SQL Server. Let's connect it. Select the database. So we are connected now. And this is our database we have created. Now we need to give our web apps managed identity access to this database. I will open the new query here. Now this command is important. We are creating a database user for the managed identity of our web app. But we are not creating another username and password. From external provider tells the Azure SQL that this user is backed by an identity from Microsoft Entra ID. In our case, That's the system assigned managed identity we just enabled for the web app. Let's execute this command. And now the Azure SQL recognizes our application's identity. But recognizing the identity doesn't automatically give it permission to work with our data. So now we will authorize it. For this demo, the application needs to read and write data. I will add the identity to db underscore data reader for read access and db underscore data writer for write access. Let's execute this command. And that's it. Our web apps managed identity is now authorized to read and write data in this database. And this demonstrates an important distinction. When we enabled managed identity on web app, we gave the application an identity. Here in Azure SQL, we have given that identity the required permission. So having the identity doesn't automatically mean having access. We still control exactly what that identity is allowed to do. So now both sides are ready. Our web app has its own managed identity and Azure SQL recognizes and authorizes the identity. But here is still one piece left. Our .NET application needs to use this identity when connecting to the database. So let's go back to the Visual Studio and configure that. Now we are back in our .NET application. Earlier we saw this connection string containing username and password. But now our Azure setup is ready for identity based authentication. So let's change the application to use that model. First, our application still needs to know which SQL server and database it needs to connect. So I will open our Azure SQL database, and from here I will go to the connection strings. As we are using entity framework in our .NET application, I will copy this connection string and let's move to our .NET application. Replace the connection string here. Now notice in this connection string one thing. There is no username, there is no password. Now we have our connection string is ready. We have the server and database information. Before we run the application, let's quickly check the data we already have in Azure SQL. I will query the employee table. Here I have inserted one demo record to get the data from our application. I will copy this employee ID. The same employee ID we will use to check our get call from the API. Now run the application. Here we have employee endpoint with ID. Let's run it. And there we go. We are getting the same employee record back from Azure SQL. But here is an important detail. I'm running this application locally. It's using my local Microsoft Entra identity, not the managed identity of our Azure web app. So this confirms that our application works with Microsoft Entra authentication without a SQL username and password. But to verify managed identity specifically, we need to run this application inside the Azure web app. So let's deploy it to the app service and test the same endpoint from the Azure. I will publish this our .NET application to our Azure Web App Service, which we have created earlier. Let's download the publish profile from here. I have imported the same downloaded publish profile here. You can do from here new profile and you can select import profile. So already I have imported the profile here. Now let's publish it. Application published successfully now. Let's check at the portal. Our application is now deployed and running inside Azure App Service. And here we can see our API running successfully with all the endpoints available in Swagger. Now let's do the final test. Open get employee by ID endpoint and I will click try it out. Let's copy the same employee ID here and execute. And There we go. We have a success response and we are getting the same employee records back from our Azure SQL database. And remember, this application is now running inside Azure App Service. There is no SQL username and no SQL password in our connection string. The application is authenticating to Azure SQL using the managed identity of our web app. Azure SQL recognizes that identity and allows access based on the permissions we configured. So, we have now verified the complete flow end to end. Our .NET application is successfully accessing Azure SQL and it's using identity instead of database credentials. No database password to store, no database password to rotate, and no database password for our application to manage. Now that we have seen it working, let's finish with the key takeaways. Now that we have seen the complete flow working, let's bring everything together. We started with a connection string containing username and password. We saw how environment variables and key vault can help us manage those secrets more securely. But with the managed identity, we changed the authentication model itself. Our application now authenticates using its Azure identity, while Azure SQL controls exactly what that identity is allowed to access. So, when Microsoft Entra-authentication is supported, we can avoid managing credentials altogether and move towards identity-based passwordless authentication. And that's what we wanted to achieve in this video. I hope this gave you clear understanding of how managed identity works in a real .NET application. Thanks for watching and I will see you in the next video.